In this little lecture, we're going to talk about multiplication, and so we'll go ahead and get started. Today, our goal is for you to be able to do multiplication with whole numbers. I also want to just remind you about the properties you're probably aware of when you're multiplying by 10. And then by the time you're done today, you'll be prepared to solve some application problems, and there will be some of those on your homework. As well as multiplication, we can think of as the way for finding the area of a shape. And so think about multiplication that way, and that will be helpful on some of these applications that you'll do after we go through the mechanics. So what is multiplication? Well, multiplication is the operation used to represent repeated addition. So in repeated addition, if we've got, for example, 3 plus 3 plus 3 plus 3 plus 3 plus 3, so these numbers here added together, we've added the number 3 6 times. And that is actually equivalent to 3 added to itself 6 times. And that is equivalent to 3 times 6. So we can really think of multiplication as simply being repeated addition. So what does that mean for us? Well, that means that multiplication is actually shorthand for something that we already understand, namely repeated addition. So I want to just really hammer in that multiplication is simply repeated addition. There are some properties of multiplication that you should be aware of, that you should be able to use. These are properties that should be committed to memory. You probably already have memorized these, but if not, make a point of doing it now. Anything times 0 is going to be 0. If you add up anything 0 times, you get 0. Anything times 1 is going to be that thing. If you add a number 1 time, you get that number. A times B is the same as B times A. So this was the same property as addition, actually. Remember, A plus B was the same as B plus A, being the commutative property of addition. We have the same property for multiplication. Okay, so let's actually work with multiplication. So remember, multiplication is repeated addition. So if we want to find 32 times 3, what's our process going to be? It's going to be to add 32 to itself 3 times. Now, this in and of itself is not really an efficient way of doing multiplication. So I'm going to show you an even harder way, and then that will hopefully help you to make sense of basically the standard algorithm for multiplication. So if I wanted to add 32 plus 32 plus 32, one way of doing that addition would actually be to add 30 plus 2 plus 30 plus 2 plus 30 plus 2 plus 30 plus 2. I could then regroup all of the 30s together and all of the 2's together. What I could really then think about that as is 30 times 3 plus 2 times 3. 30 times 3 is easy to do in our head, that's 90. And 2 times 3 is fairly easy to do in our head, that's 6. Just to remember, why would 30 times 3 be 90? Well, that would be 30 plus 30 plus 30. Adding down the column, I get a 9 and a 0. So I've got 90 plus 6. Well, what is 90 plus 6? Simply 96. Okay, so we can say that 32 times 3 is 96. That may seem like a really complicated process in order to do something that's very simple. And in fact, that is a complicated process, and I would never want you to actually go through all of those steps to solve the problem. But I want to point out what you've actually been doing in all of this. You've been doing what is considered the sort of standard algorithm for multiplication. Namely, if I take 32 times 3, I take 3 times 2 is 6. And then I take 30 times 3, which is 90, and that gives me 96. So I want to emphasize that actually this algorithm, that is the standard algorithm, comes from repeated addition. Okay, so I'm going to carry that through on the next slide just so that you can sort of walk through it step by step. So what we really do in the standard algorithm is we take 32 times 3, and then we multiply the 3 times the 2 to get 6. We multiply the 3 times the 30 to get 90. we add those up and we get 96. So this is the standard algorithm, just to put some notes on it so that you sort of know what's going on. 3 times 2 gives me 6. 3 times 30 gives me 90. And so that gives me 96. What we're actually really relying on is what's called the distributive property of multiplication. That is that if you have A times the quantity, or the parentheses, B plus C, that's the same as A times B plus A times C. So that's what's called the distributive property of multiplication, and your standard algorithm relies entirely on the distributive property of multiplication. So 3 times 30 plus 2 is 3 times 30 plus 3 times 2, and we know that is 96. Let's go ahead and do another example, a more basic example again, like we just did. And so let's say that we're looking to do 46 times 5. So what is the first step going to be? The first step is we're going to multiply our 5 times 6 and our 5 times 40. So we're going to do 5 times 6 and 5 times 40. You might actually want to be thinking about this as really, so this is the same as 6 times 5, and this is the same as 40 times 5. If I were to do this via repeated addition, I'd have 6 plus 6 plus 6 plus 6 plus 6. But we all know from our multiplication tables that that's simply 30. And if I were to do this one, I could think of this as 40 plus 40 plus 40 plus 40 plus 40. But we know from multiplication tables that 5 times 4 is 20, have an extra 0, so we get 200. So that's the basic idea behind it. What it looks like, though, in work is we're going to take 5 times 6 and get 30. And we're going to take 5 times 40 and get 200. Then we're going to add those numbers together to get a total of 230. So this is the standard algorithm, the standard way of handling multiplication. What about something like 146 times 25? So here things get a little bit more complicated, but we can still handle this with the standard algorithm. So what do we know? We know that we're going to multiply out individually. So 5 times 6, I'm going to say 5 times 6, I get 30. I'm going to take 5 times 40. One way that people like to do this actually is they'll like to write a 0 here and then just consider this as 5 times 4. And that's fine. That's 20. Now I have 5 times 100. More often what people like to do is fill in 2 zeros and just say 5 times 1, which is fine. And so that's a 5. So that gives me the 5's place. Now I have the 20's place. So how do I handle the 20's place? Well, one thing that I can do is I can think of 20 as really 2 times 10. So I can add a 0 here and just handle it in the 2. So 2 times 6 is going to be 12. I have a 0 from the 20, plus I have a 0 from the 6 now. 2 times 4 is going to be 8. A 0 from the 20, a 0 from the 6 place, a 0 from the 4 place, and I have 2 times 1 is 2. So then I can add all of those together. When I add them all together, what do I wind up with?